There are so many products. There are different types of products, tons of manufacturers. So, how do we begin to talk about that? Um, let's talk about where insulation goes and what kind of insulation you are likely to find in those locations. When we're looking at exterior insulation, it's almost always going to be in the form of a board. I've got rigid written down here. That generally refers to foam boards, but boards can also come in the form of, can be made out of compressed fiberglass or rock wool. So in roof and walls, you're generally going to find board form. I mean, there's in commercial applications, you also might have high density spray foam on walls and roofs. Cavity insulation. Insulation you're going to find in a cavity will be blown in. It might be spray foam again, or bats. Now, the thing to note about cavity insulation is that it's going to be limited. The amount you can get in is going to be limited by the depth of the cavity. So that may seem obvious, but if you've got an insulation requirement for your climate zone, and you've got a 2x4 wall, there are limitations to how much R value you can get into that limited space. So that's one consideration. It means that you may have to put exterior insulation in your wall assembly in addition to your stud cavity insulation, and again, that would be dictated either by your project goals or by your code requirements, your climate. And the second thing to note about cavity insulation is that if that's your only type of insulation in your wall assembly, that you necessarily are going to have thermal bridging occurring, because you haven't, with stud cavity insulation, you have not created thermal breaks at your studs and your framing members. There is also structural insulation. That would be your SIP panels, your mass walls, your integrated concrete forms, auto-aerated concrete blocks. We won't get into structural insulation. It's a big topic, but those products are out there. And interior insulation is fairly uncommon, so we won't talk a lot about that, but if you had it, it would likely come in a board form as well. So what types of rigid or board form insulation are out there? These are the most common. We've got XPS, which is extruded polystyrene, not to be confused with EPS, which is expanded polystyrene. The manufacturing processes of these two foam products is different, and they resultingly have some different material properties, which we'll talk about a little bit later. Other products available in board form are, as mentioned before, rock wool and also fiberglass. So with rigid foam board insulation, you can use, this is an example when you can use your thermal control layer as your air control layer as well, but in order for it to function as your air control layer, it has to be taped and seamed. It has to be taped at its seams, and it has to be sealed at any penetrations. It's not magic. Just because you put it up doesn't mean you're not leaving gaps through which a lot of air can get through. So while that might be a very effective, you could have a rather effective thermal control layer, even if you were to leave cracks in the installation, like between boards and at seams, it would not serve well as an air barrier. I guess I could point out that blue board, there are other, I'm obviously showing a Dow blue board insulation there for XPS, and it comes with a tongue and groove option, which if is a good option if you're trying to use it as your air barrier. Owens Corning also makes a foam board, and there are other manufacturers and products available as well. Next type of insulation that we're going to look at is blown in, also called loose fill. It depends sometimes on where it's going. If it's being applied to an attic floor, a lot of times it'll be referred to as loose fill. It just depends. Some of these terms are interchangeable. So first we've got cellulose, which is a recycled product. We've got rock wool, which is also a recycled product. It's using slag from the steel and copper industries, and fiberglass blown in. These are the three most typical insulations. So we're going to pick a little bit on these fibrous blown in loose fill insulations, really just to make the point that they cannot serve as air barriers. This is a common misunderstanding. I get asked with some regularity whether or not someone's cellulose will function as an air barrier, and the answer is it will not. Conduction, convection, radiation occurs in fibrous insulation. The convection mode of heat transfer can be significant in fibrous insulation. On a larger scale, here we're showing how it can move between fibers of the insulation, and that is to be considered, but is not considerable compared to the convective loops, which can occur when the insulation is too loose, or when settling has occurred and there are considerable gaps in air spaces within which convective loops can occur. So we don't want to belabor the point, but we do want to drive it home. Your blown in and loose fill insulations will never serve as an air barrier. Fluffy stuff cannot be an air barrier. So that is the takeaway from that. Spray foam is another type of insulation that's commonly in use. In residential applications, it's usually open-celled. Spray foam, open-celled, is considered a low-density spray polyurethane foam. It comes in a range of 0.5, a density range of 0.5 pounds per cubic foot to maybe 0.7 pounds per cubic foot. We have medium density, which is referred to as closed-celled spray foam. It's generally on the order of 2 pounds density, and high density closed-celled spray foam, which is generally on the order, again, of 3 pounds per cubic foot. And the application for high density closed-celled is something you'll almost never see in a residential application, and will not see used in interior spaces. Generally, it would be applied on a roof or on exterior walls. So spray foam is another example where your insulation can act as an air barrier. For open-celled spray foam, you generally need 3.5 to 5.5 inches. It depends on the product and the actual installation. It's not magic. It's really important to make sure that the installation was done properly. And in our next section of this presentation, we will discuss some things to look out for, particularly when we're looking at open-celled spray foam applications and installations. So before we leave this section, We talked about location of insulation, so I'd like to just address the ideal, um, the general theoretical ideal for where you'd like to put your insulation. We've already touched on this a little bit because we talked about thermal breaks and the importance of creating those thermal breaks. This slide shows one iteration of a perfect wall. This is from the Building Science Corporation, one of their many iterations of the perfect wall. So this example has a brick veneer and it's got steel studs. We could just as easily be talking about stucco and wood frame. But generally, if we look through the cross section, what we have is some exterior siding, cladding, veneer. Behind that, we would want to see a drainage cavity or gap to allow for bulk water to run down and out of your assembly. After that, we would want, ideally, we see our insulation. So insulation goes on the outside of an ideal building assembly. And again, this is dependent on your project and maybe your climate even. But when we put our insulation on the exterior, we create thermal breaks in our building assembly so that our framing members are not conducting heat through them. That is the main advantage of putting that insulation on the outside. Another advantage is that you have the opportunity here to use that thermal control layer, or at least a piece of the thermal control layer. And I say a piece because you will often find exterior rigid insulation plus stud cavity insulation using combination. That is a very common assembly. But what I was saying is that you have the opportunity to use your exterior insulation also as an air barrier. Again, if it is taped and sealed, it can function that way. So behind that, you would have your water resistive barrier, which could serve as your water, air, vapor control layer, redundancy for your air control layer, perhaps. That would be peel and stick or fluid applied on sheathing. Then you've got your stud cavity, which would be filled with insulation of your choice, and then probably sheetrock and a vapor permeable paint on your interior side. So coming up next, we will be talking a little bit about material properties of insulation.